Alright, so today we're talking about inscribed angles. And up until this point, we've really just talked about central angles. Now, if you'll remember with central angles, our central angle's vertex is at the center of the circle. And the central angle, if the central angle was 60, then the arc that goes with it would also be 60. Today we're moving to talk about a second type of angle, and that is an inscribed angle. So we're just going to jump right in. Okay, so on your foldable, an inscribed angle is an angle with the vertex on the circle, and the legs of the inscribed angle are chords of a circle. So if you look at our first picture here, we've got our inscribed angle theorem. We have the measure of an inscribed angle equals half the measure of the intercepted arc. Now, intercepted just means the arc that's in between the angle that we're talking about. So if you look at this picture, we see that our vertex of this angle is E, and E is located on the circle. The chords of the inscribed angle would be ED, and the other chord would be EF. So that's the angle we're talking about, which means the arc, the intercepted arc, would be arc DF. Okay, so arc DF would be our intercepted arc that we're talking about. So if the angle is half the measure of the arc, then when we go from the arc to the angle, we are dividing by 2. Now, if we're going from the angle to the arc, then we would be multiplying by 2. Okay, so let's look at some examples. Okay, this first example is pretty straightforward. Okay, we want the measure of angle KNL. Angle KNL is this angle right here, and that's what we're trying to find. We know that this arc is 62 degrees, so to go from the arc to the angle, we need to divide by 2. So we would just say 62 divided by 2, which equals 31. So the measure of angle KNL would equal 31 degrees. Okay? So the second one is a little bit different, okay, because they want us to find the measure of angle QRS, which would be this angle. Okay? To get that angle, we don't know the arc that goes with it, QS. Okay, but we do know the other two arcs. We know that we have 140 and 120, and we know that there's 360 degrees in a circle. So our first step is that we need to add 120 plus 140, which gives us 260 degrees. Then we know that a full circle has 360, so we're going to subtract 360 minus 260, which gives us 100. That 100 represents this arc, arc QS. Okay, now that we know that the arc QS equals 100, to go from the arc to the angle, we just have to divide by 2. Okay, so we would say 100 divided by 2, which equals 50. So the measure of angle QRS equals 50 degrees. Now, our easy way to remember this, if you need a little formula, would be that the angle equals the arc divided by 2. Okay, or we could say the angle equals 1/2 times the arc. Multiplying by 1/2 and dividing by 2 are the exact same thing. Okay? So we're going to keep on moving right along. Okay, so our second theorem says if two inscribed angles create the same arc, then the angles are congruent. So they say angle VTU is congruent to angle UWV. So let's look at angle VTU right here for just a second. Okay, angle VTU is this angle right here. That angle intercepts arc UV. The other angle we're talking about is angle UWV. So W to V, and that angle also intercepts the same arc. So if they intercept the same arc, then they have to be the same measure, because you're going to divide by 2 and get the same thing for both. So if we look at the example on the inside, then they ask us to find the value of x, and then the second part's going to be to find the value of y. So the first thing we look at is where are our x angles. So here's an x angle, and here's an x angle. Okay, now if we look at this, angle B right here goes with angle ABD, which goes with arc AD. Okay, then we look at angle C, and angle C also goes with arc AD. So we know that because they share the same arc, that those two angles are equal. So we would say 6x minus 3 equals 7x minus 11. And then we're just going to solve. So I'm going to subtract 6x on both sides. Whoa, got a little crazy there. Okay, we've got negative 3 equals x minus 11. Add 11. And you end up with x equals negative 3 plus 11, which is 8. Okay, now if they would have asked for the arc, okay, or the angle, then you would just plug it back in, like we would just say, if they wanted angle B, right, then angle B would equal 6 times 8 minus 3, which is 48 minus 3, which is 45 degrees. Okay, and so if this angle was 45 degrees, then this arc, we would multiply by 2, so arc AD would equal 90 degrees. Okay, so make sure that you're just being careful what they ask for. Okay, and then your second one here, we're finding the value of y. So we've got a y angle here, which goes with arc BC. And we've got a y angle here at D, and that also goes with arc BC. So we know that those are also going to be equal. We're going to say 6y minus 2 equals 5y plus 8. And then we are solving, so we're going to subtract 5y. We get y minus 2 equals 8. Add 2. And we get y equals 10. Okay? So, if the angles share the same arc, then they are congruent. That is theorem number 2. Alright, so on to theorem number 3. Okay, if an inscribed angle intercepts a diameter, then the intercepted angle is equal to 90 degrees. Okay, so here's what we're talking about. On this picture, we know that the diameter would be WX because it goes through the center. So we know that this arc here has 180 degrees. Okay, this angle, angle Y, is inscribed because the vertex is on the circle. Okay, and its endpoints are on the diameter, which means we would go 180 divided by 2, which would give us 90. So we know that angle Y would equal 90 degrees. And we also know, because it's a triangle, that angle W plus angle X would equal 90 because our triangle has to have 180 degrees in it. Okay. So, on our examples on the inside, what we're looking at here is, do we have a diameter? And we do have a diameter. We have RT. And does angle S endpoints are on the diameter, then angle S would be 90 degrees. If angle S is 90 degrees, then our other two angles have to add to equal 90 degrees. So we know that angle R plus angle T equals 90. So we're going to say 2x plus 4x minus 6 equals 90. And then we're going to solve. So 6x minus 6 combined like terms equals 90. We're going to add 6, and we're going to get 6x equals 96. And when you divide by 6, you get x equal to 16. Now, if they would have asked you for the angle measure, then you would just plug it in and get the answer. Okay, now the second one says just what is the first step, but we're just going to solve. We're going to go ahead and solve for x. Okay, again, we're looking at this angle, angle H. Its endpoints are on J and K, which means it's a 90-degree angle. Okay, which means that angle J and angle K have to add to equal 90. Which means we would say 5x minus 2 plus 2x plus 8 equals 90. So we get 7x plus 6 equals 90. Subtract 6. We get 7x equals 84. Divide by 7. And you end up getting x equal to 12. Okay, we're going to see that one a fair amount. So make sure that you're understanding that one. Because that 90 degree is going to come into effect. Alright, now let's move into our last inscribed angle property. Okay, theorem 4 says if a quadrilateral is inscribed in a circle, then the opposite angles are supplementary, or they equal 180. Okay, the reason that is because our whole circle has 360 degrees, and if it's inscribed, like here, okay, if we're talking about angle P goes with this arc. Okay, and then we've got its opposite angle is angle R, which goes with this arc, which makes our full circle. So 360 divided by 2 is our 180. So those angles have to equal 180. Okay, so when we have what we're looking at here, then we would know that angle P plus the opposite angle R equals 180. And the same is true for the other end. So angle Q plus angle S also equals 180. Okay, so let's go look at some problems on the inside here. Okay, when we're looking at our first example, they want us to find x and they want us to find y. Okay, so we are looking for the x and the y in the problem. So here's x plus 18. And here's our other x's, 2x. And we know that w and y are opposite angles, which means that they have to equal 180. So we've got 2x plus x plus 18 equals 180. 2x plus x would be 3x plus 18 equals 180. I'm going to subtract 18. Get 3x equals 162. And then we're going to divide by 3 on both sides to end up with x equals 54. Okay. So similarly, we have our y's, which is my 3y minus 7 and our 3y plus 1. And we know that this angle z and this angle x also have to add to equal 180. So we're going to say 3y minus 7 plus 3y plus 1 equals 180. We're going to combine like terms, so we get 6y minus 6 equals 180. And add 6. We're going to get 6y equals 186. And you divide by 6, you end up with y equals 31. Okay. So last example, let's just solve for y on this last one real quick. We've got 11y and we've got 7y. Those are opposite angles, so we can say 11y plus 7y equals 180. Got 18y equals 180. And divide by 18 and you get y equals 10. Okay. Now, there's one more thing I want to show you that is not on your notes that I just want to talk about. Okay, and that's when you have a central angle and an inscribed angle in the same circle or when you're going through the diameter. So if we look at one more thing right here real quick, I'm going to give us two different circles and we're going to do two different problems and then we'll call it quits. Okay, if we are looking at our circles here, let me put in some lines here for us real quick. Okay, let's say that we've got our central angle going here, and then we've got this angle going right there. Okay, let's say that I tell you that this is A, B, C, and D. Okay, if I tell you that angle ACB is 110 degrees. Okay, and I say, what is the measure of angle ADB equal to? Okay, the measure of angle ADB is this angle right here, and that's what we're trying to find. Okay, we have to use that 110. That 110's vertex is at the center. So we know it's a central angle, which means the arc is the same as the angle, which means arc AB is 110. If I know the arc that is on the intercepted arc of my inscribed angle, then we can go arc to angle by dividing by 2. And so you could say 110 divided by 2, which gives us 55 degrees. Okay, and then your last one for today is if we have this line right here, and we are going this direction. Okay, if we know that this angle is 28 degrees. Okay, let's put some letters on our picture. We've got M, L, P, and we'll call the center N. Okay, so N is the center of our circle, and we are trying to find the measure of arc LM. Okay, the measure of arc LM is right here, and we don't have any angles going to that right now. Okay, but we do know that N is the center, so we know that this whole arc ML to P, is 180 degrees. So if we use that 28, we can find the arc LP by multiplying by 2. So 28 times 2 equals 56. So we know this arc is 56. And if we know that arc, and we know that arc MLP equals 180, then to find arc LM, we would say 180 minus 56, which ends up giving us 124 degrees. Okay, so inscribed angles are super important. Please don't get them mixed up with central angles, because they are two completely different things. Again, if you ever have questions, please come and see me or send me an email, or try another video.